Sketch the following piecewise function. So we're going to start by placing the x-axis and the y-axis, and then we're going to indicate the different regions where we have the definitions of the functions. So the first one is going to be when x is less than -2. So here x is -2. And the next one is going to be between -2 and x equals to 1. So here x equals to 1, and then the third one is going to be when x is greater than 1. Okay, so for the leftmost region, the function is defined as x plus 5. This is a linear function, and this is defined when x is less than -2. So this means that we have a linear function that will, at -2, the y-coordinate is going to be 3. And there's your y-coordinate, and then it's a straight line with a positive slope, so something like that. The x-intercept here is going to be -5, so we would simply take x plus 5 and equal it to 0. The y-coordinate at the x-intercept is 0, and solve it for x, which will give us a -5. Within the second interval here, in the middle interval, the function is defined as a quadratic function. It's a parabola that opens up, and the -1 means it's been shifted down 1 unit. So instead of going through the origin, the y-intercept is going to go through x equals -1, and then it's going to come up and cross the x-axis at 1, and x has to be less than 1, so we're not going to include that point. And it's going to look something like this. And then finally we have an absolute value function or definition here. The absolute value of x minus 3. So the an absolute value function, so here's x and here is the absolute value of x, looks like this. Now the -3 means it's been transformed and it's been shifted 3 units to the right. So it's going to touch the x-axis at x equals to 3. And then it's going to go up like this, down to x equals 1, and then up like that. And this point right here is included because this function is defined as the absolute value of x minus 3 when x is greater or equal to 1. So we're including that point.